This section is section 10.1 on ellipses. And this is the first of the 3 conic sections we are going to study. Now the 3 conic sections that we'll get to, you can actually see them if you look up what a conic section is on Wikipedia. One of them you'll be familiar with a little bit, which is a parabola. An ellipse is what we're going to talk about here first, and it's sort of going to be this oval shaped thing, and then the one that you might not be familiar with at all that we'll get to in the next section is the hyperbola. But the reason they're called conic sections is if you take a cone, which in math is an infinitely long double-sided cone, not just the way you would think of 1/2 of a cone, like an ice cream cone, and you cut them with stuff, you get these shapes. So that's where the name comes from. As far as using resources for this stuff, there's a lot of different types of formulas depending on what you're going to deal with. So what I'm showing you today is really what you need to know. There's a lot of stuff about conic sections, but you should really just take in the points that we're going to be talking about here. Right, so as far as ellipses go, the first thing that we'll see is the equation of an ellipse, the important stuff like I mentioned. Whatever I don't talk about, you don't need to know. There's a lot of little things, but don't worry about them. And then we'll just work with the equation for a little bit, and we'll also see a couple of applications, a couple of word problems at the end. So now, to talk about the equation of an ellipse, it's very hard for me to draw on this, so I've already pre-drawn everything, but I'll talk about everything that's going on here. Like I mentioned before, an ellipse is like an oval shape. You're probably familiar with an oval. You may already be familiar with an ellipse, but an ellipse is the oval shape. And a lot of things in real life actually follow ellipses, which is why they're studied. All these conic sections pop up all the time in a lot of physics classes, especially if you study things in space. Alright, so what we're going to be doing here, we're going to restrict, only talk about ellipses centered at the origin. And we're going to have 2 formulas that are going to look almost exactly the same. The one on the left here, we have x squared over a squared plus y squared over b squared equals 1. And then on the one on the right, it looks the same. We just switch the a and b. It's x squared over b squared plus y squared over a squared equals 1. The difference in these two, switching the a and b, is the a is going to be the bigger number of the denominator, which is going to be an important property of the ellipses. Right, so, excuse me. Right, so if the bigger number is under x squared, then it's going to have a horizontal major axis. And what goes on if you have a horizontal major axis? Right, you can see the picture I've drawn here. The gray part is supposed to be the ellipse. At the ends on the x-axis, at negative a and a, which correspond to the same a right here, are what we call our vertices. And then somewhere in between here, there are these 2 special points labeled by the letter C and negative C. These are called foci. These aren't actually on the ellipse, but they are very important characteristics to the ellipse. But one thing that's very important about it is they live on the major axis. So wherever your major axis is, your foci must be there as well. The other 2 special points about an ellipse are the opposite vertices. So the vertices not on the major axis. And these are called the co-vertices. Here, for the horizontal major axis, they are on the y-axis because this is not the major axis. Now, the same thing happens here with the vertical major axis. Everything follows in a similar fashion. Except that your major axis is vertical, so the vertices are still at the ends labeled by the letter A and negative A. The foci are somewhere in between, labeled by C and negative C, and the co-vertices are now on the x-axis because that is not where the major axis is, at B and negative B. Okay. Now there are a few things I want to point out here. I have these labeled at the bottom. One thing that's going to be very, very, very important to this stuff, when you're dealing with ellipse, the way you know you're dealing with an ellipse is this plus in between. Okay? If there is not a plus in between, if there's a minus in between, that is something else. That'll actually be a hyperbola, and they look very different. So you got to remember that when you see a plus in between the x squared and y squared, that means that you have an ellipse. The other thing that I already mentioned here, I'll just kind of like star all these so I don't accidentally write over some of them. But a squared represents the bigger denominator, b squared represents the smaller denominator. So you'll see when we go through our problems, I'll be focused on the thing that has the bigger denominator in a lot of the problems for that reason. Right, because that's where the major axis is, that's where the foci are going to be. Another thing that you may have noticed about the two formulas above is they both have equal to 1 on the right side. That is very important. Pretty much all our problems are going to be set up perfectly when you look at the homework. But in theory, if you had an equation of ellipse and 1 was not over here, let's say 10 was over here, to get 1 over there, you divide everything by 10. So you could easily make that fix. The fourth point here, that's kind of what I mentioned a couple times already, but it's worth mentioning over and over again. The larger denominator dictates everything that's important about the ellipse. The vertices and foci are really the two important parts of the ellipse. And the last thing is, how C interacts with A and B. This is not at all obvious how you would figure out C in a problem because it's not actually on the ellipse. But we have this formula here, C squared equals A squared minus B squared. It looks a little bit like the Pythagorean theorem formula. The reason why it's not C squared equals A squared plus B squared is since A is the biggest one, it goes in the front. That's one way to help remember that. But this is for an ellipse only. This is not going to be the same formula for the future sections. I'm just going to write that in there. Once again, I apologize, but I am writing with my mouse, so I'm trying not to write too much on here. All right, but that's really the background. We'll go ahead and look at some problems now. The first thing that's probably going to be the easiest thing in this section is if you're given a graph, how do you figure out the equation of the ellipse? And the reason it's the easiest is the foci here do not matter at all. You won't have to worry about that C. And so anytime you want to figure out the equation of ellipse, well, the first thing to notice about these graphs is it is an ellipse. Hyperbolas and parabolas will look very different. Since these are ellipses, we can automatically sort of form our equation x squared plus y squared, because we have that plus there. I'm going to leave the denominators blank for the moment, and this is going to equal 1. Now what goes under the x squared and y squared are just going to be the numbers where it intersects the x in the y axis. Okay. So what I'm drawing here, from the origin to one of these points where it hits the x-axis, is going to be A, because this is the center. The origin is the center, and this is one of the vertex or co-vertex. It doesn't matter for this problem specifically. But what this is telling us is that the number under x is 4. Oh, that is terrible. Let me erase that real quick. drawing an arrow. So I'm not over it. But this, what this is saying is the number under the x is 4. But it's raised to the second power. And so whether it's actually a or b here doesn't specifically matter. Just because we're plugging in numbers into the equation, we're not actually dealing with what's the focus and all the other special things. All right, so the number under the x squared is 4 squared, which is 16. Let's go ahead and draw that in under my x squared. We'll have 16. And you do the same thing for the y. So if we look from the center up to where we hit the y-axis, we can see that is going to 2. So the number under the y squared is 2 squared. Which simplifies to 4. We're going to put 4 under the y squared. Right, and that is actually it. That's all we need to do. That is the equation for this ellipse right here. X squared over 16 plus y squared over 4 equals 1. Now, just comparing to our notes before, we would realize that a is 4 and b is 2 because a is the bigger number here and b is the smaller number. This is a squared and this is b squared. And that'll be more important in the next section. But the next problem is pretty much exactly the same. It doesn't matter, looking down here, that the major axis is going to be vertical. It's longer, it's taller than it is wider, which means the major axis is vertical. But the idea is exactly the same. That part really doesn't matter for this type of question. Since it's an ellipse, we have our x squared and our y squared connected by a plus. And the number that goes under the x squared is the 1 squared. Right? Is here a is 1, or b is 1. So we're going to put 1 squared under x squared, which is 1. And then the vertical side for y, it's going up to 4. What that's telling us, since that's the bigger one, is that a is 4. And under y squared goes a squared, which is 16. The equation for this ellipse is x squared over 1 plus y squared over 16 equals 1. And of course, if you don't write the over 1 part, that's fine. You can just write x squared plus y squared over 16 equals 1. Now going forward, the problems, you'll see it's going to matter what we're looking at, what goes under the x squared and y squared. Okay, so the next couple here, they give you descriptions and they want you to come up with the equation of the ellipse. So it says, give the equation in standard form. That's what we've been talking about. Just the same thing from before. Give the equation in standard form of the ellipse centered at the origin. That's always going to be true for us. We're only dealing with the center at the origin. A focus at 0, -2. And a vertex at 0, -4. Now, what I have outlined above here, which I kind of skipped over too quickly, but memorizing a whole bunch of formulas is not necessary. You need to definitely memorize the basic formulas that we talked about up here. You know, what the equation of the ellipse looks like, and you need to memorize this equation for figuring out C. or b, just how they're all related. C squared equals a squared minus b squared. But you don't need to memorize more than that. Okay. So what you really want to do is kind of just sketch out a little picture here. You're not going to be able to draw much of it, but you know that it's an ellipse. It's centered at the origin. So don't make too much fun of my drawing. That's my ellipse. It has a vertex at 0, -4, which is right there. I like to label things with names, so I'm going to write this as a V to know this is a vertex. And it has a focus at 0, -2, so a little down here, about halfway between -2, and that is a focus. I'll label that with F. Now I know the way I drew this, it looks like it's wider than it is taller, but that's just me drawing. The major axis must be this vertical y-axis, because that's where the vertex and focus are. Let's go ahead and write that in. The major axis is vertical, since the focus and vertex are on the y-axis. That's just something to make a note of. But if we know the major axis is vertical, we know the bigger number will go under the y squared. So we're going to have x squared over b squared, remember that b is designated to be the smaller one, plus y squared over a squared equals 1. And our job is to figure out a and b. And if we figure out what a and b are, then we are done. We just plug them in like last time. Okay. Now one thing you want to remember is a represents the distance from the center to a vertex. And the center is at the origin. So you can go ahead and even label that in. The center is always going to be at the origin for us once again. But the distance from the center to a vertex is what a is, and that is 4. See the best way to try to draw this in. So that would be the distance there. And a means the distance from the center to a vertex, which is 4. So already, just from looking at that, we know that a equals 4. Okay. The question is, what is b? Well, b would represent wherever we're hitting the x-axis over here, but we can't see that at all. It could be anything less than 4. It could be 1, it could be 2, 3, something very different than that. So what we have to do now is use that formula to figure out b. Let me go ahead and write that in. To get b, we will use the formula c squared equals a squared minus b squared. And another thing I will go ahead and point out is we know what c is, because c represents the distance from the center to a focus. So I guess go ahead and write that in as well for this first one. Make that cream to line it up, and the distance from the center to a focus, 0 to -2, is 2. So we know that c is 2. Okay. So we'll go ahead and plug this in. Plug in A and C and we can get B. We got 2 squared equals 4 squared minus B squared. 2 squared is 4, 4 squared is 16. So I'll just go ahead and write subtract 16. That way I don't have to write too much on here and make it look too weird. So 4 minus 16 is negative 12. Negative 12 equals negative B squared. And if we continue solving, we can knock off the negative of each side here. And then we got B squared equals 12. Now if you realize what we actually want in the formula, which is B squared, you could stop here. You can just plug in 12 right there. If you want to write down what B is, which is fine, we would do the square root of each side. B is a distance, so it can't be negative. And you know well enough now that I don't mind if you don't simplify square roots. B is the square root of 12 is plenty good. Right, but if we go ahead and plug in our A and our B, we got, let's see where to plug this in. Alright, we got A is 4, so A squared is going to be 16. B squared is 12. Let's see how well I can write that. We get x squared over 12 plus y squared over 16 equals R1. And that is the equation of our ellipse. And that's really about as complicated as these will get. You just got to one thing to keep in mind is as we go through this chapter and we have more equations, they're going to look very similar, and that's where the hit and miss kind of part will come in. You don't want to confuse equations from one section to another because they look similar but are different. All right, we'll go ahead and do one more. Figured this one, if you draw out the picture, it might look a little strange at first, but it's nothing to worry about. Okay, so we want to do the same thing. We want to give the equation in standard form of the ellipse centered at the origin with a focus at -1, 0 and a vertex at 5, 0. And then our center is at the origin. And so if you do want, then just kind of sketch out a picture like last time. It doesn't need to be super specific. Just draw a ellipse as best as you can and label as much as you want. If you don't like labeling the center because it's always the origin, you don't have to. That doesn't even look like a C. Get rid of that. But we have our vertex is at 5, 0. The vertex is where we hit the axis. And our focus is at -1, 0. And now this time you can tell because our vertex and focus is on the x-axis, our major axis is our horizontal axis. And because of that, the a squared goes under the y squared. Let's go ahead and write, the a squared goes under the x squared. We have horizontal major axis. You can just see that it's the x-axis, which would be plenty good. Horizontal major axis, a squared goes under x squared. ahead and write that in. We got x squared over a squared plus y squared over b squared equals 1. And all the same things apply as last time. A is the distance from the center to a vertex, and that here is 5, so A is 5. And C is the distance from the center to a focus, so that means C is 1. And remember, these are all distances, so they're always positive. A, B, and C are always positive. And just like last time, we have a squared and b squared in our equation. We need to figure out b squared using the same formula. Right, so we got c squared equals a squared minus b squared. And if we plug in, our c is 1 and our a is 5, just like last time. We got 1 squared equals 5 squared minus b squared, which is 25, so subtract 25 from each side. One minus 25 is negative 24, equals negative b squared. We can knock off the negatives on each side. Now we got b squared equals 24. And like we said last time, you can just realize that's what's going on in the equation and stop there. I mean, we can just put the 24 in right now and be done. If you want to go ahead and write, what b is, b would just be the square root of 24. Right, but we want to put a squared and b squared in our formula. Go ahead and plug that in. Since a is 5, a squared is 25. Since b squared is 24, we can just directly put that in, and that equals 1. And that was a terrible line. Let me get rid of that real quick. And that is our final answer. You want to just leave your equations like this. You don't want to rearrange them at all. You're done. The whole goal of what we're going to be doing with ellipses, when we get to hyperbolas, when we get to parabolas, is figure out what equation you're going to use and find the missing letters. When for an ellipse, that's a and b, or a squared and b squared. All right, so the last thing may not be as challenging as the previous one, may be more challenging, just depends on what seems to be more comfortable to you. But this time we're going to be given the equation and we want to find the foci and vertices. I want to find both foci and both vertices. And this is going to also call into play that you understand that the foci and vertices come on the major axis. The major axis corresponds to what denominator is bigger. Okay, so just looking at this first one, we got x squared over 16 plus y squared over 7 equals 1. What you want to realize here is that 16 is definitely bigger than 7, which is under x squared. So we have the bigger denominator under x squared, which means the horizontal axis is our major axis, or the x-axis rather. So the vertices and the foci will both be on the x-axis. And I do recommend, once again, just drawing a little sketch out. Don't have to be too precise, but it's definitely very helpful moving forward. We have an ellipse. The horizontal axis, or the x-axis, is our major axis. The vertices are at the edges here, so there's going to be one right there, one right here, and the foci are somewhere in between. one thing you want to just write down, like last time when we were given the foci or focus and vertex, we wrote down what A and C were. Now we can write down what A and B are, or A squared and B squared. Right, so remember the denominators are not just A and B, they're A squared and B squared. A squared is the bigger one, which means A is 4 if we do the square root of each side. And B squared is the smaller one. Yeah, make sure I write that in the same color I've been using, which is blue. Okay. We got B squared is 7. That doesn't simplify too well. We can write that B equals the square root of 7. But the thing you want to realize is now what we need to figure out is C. We can write down the vertices because we know they're 4 away, but we need to get C. And to get C, we have to use that same formula again. We got to use C squared equals A squared minus B squared. So C squared equals A squared minus B squared. Right. And then realizing that you already have A squared and B squared in the formula, you don't really need A and B for this. You just use A squared and B squared. We get C squared equals A squared, which is 16, minus B squared, which is 7. 16 minus 7 is 9. And the square root of 9 to get C is 3. Now you have what A and C are, so we know this vertex is 4 and 4 away. We know the foci are 3 and 3 away. We actually want to write them out as coordinate pairs because they are points on the graph. Okay. So the vertices as coordinates. Right, the one on the right over here would be 4, 0. And the one on the left would be negative 4, 0. If you want the foci, that's 3 away. Oops. Go ahead and do that. The foci. The one on the right here would be 3, 0. And the one on the left here would be negative 3, 0. And that's pretty much all there is to all the problems in this section that aren't word problems. But I do have one more because usually what happens is we see these perfect squares like 16 and we want to focus on them, so I just want to really reiterate what's important here with one more problem. Alright, so same deal, we want to figure out the foci and vertices of this ellipse, which is x squared over 36 plus y squared over 45 equals 1. And you cannot focus on this 36 here even though you want to because it's a nice square number. The bigger denominator is 45. The bigger denominator is 45, that means our major axis is the y-axis. It's on the y-axis. Let's go ahead and write that in like we have been doing. So that means the vertices and the foci will be on the y-axis. So you can give yourself a little sketch. And I'll reiterate, I'm no artist, I'm not trying to be an artist, it's just to give you a visualization of what's going on. Right, so that is our major axis, vertical major axis. The vertices are at the top and the bottom. The foci are somewhere in between. And remembering what's going on here, the a squared is the bigger number. So a squared equals 45, and that means a is the square root of 45. Yeah. Because this will be part of our answer, because a is going to tell us the actual coordinate here, you might want to simplify this for the homework. The square root of 45 simplifies to 3 times the square root of 5. Now b squared is the smaller denominator, which is 36. And if you want to write down what b is, you can. It's not really important here, but b equals 6, square root of 36. The important thing is to, once again, you need to figure out c to figure out how far away the foci are. And the only formula you have for that is c squared equals a squared minus b squared. You will never have another tool to figure that out. Well, let's go ahead and plug it in. A squared is 45. B squared is 36. And 45 minus 36 is 9. C squared is 9, and then do the square root, and we get that c equals 3. And now once we've got a, we know exactly the coordinates of the vertices. Once we got c, we know the coordinates of the ellipse, or sorry, the coordinates of the foci. This is why drawing your picture is so helpful, is that everything is labeled there for you. You don't have to figure out what A, B, and C are, and then if you don't have your picture, you might get something backwards. It's very, very easy to do. Right? So the y coordinate of the vertices, x is 0, y is 3 times the square root of 5. And exactly negative of that down here, so 0 and negative 3 square root of 5. And the foci, C is 3. We got one up at the top, 0, comma 3. And we got one at the bottom, 0, comma negative 3. But once again, that's really all there is to it. For all the problems that aren't word problems, it's just practicing the formulas, getting used to everything. Especially if you are someone that's going to take physics, you'll probably see the equations of an ellipse, equation of a hyperbola, plenty. You'll probably see parabolas too, but you already, like I said, you've already studied those a little bit. But the last thing in this section are word problems. This is the only section in the rest of the class that has any word problems. We're going to have any word problems for. And I have 3 on the homework, and I'll do 2 of them here. The other one is the only one that actually has a picture drawn for you. So if you can do these 2 without the pictures, you can do that one with the picture. Number 1, the first one I have here, it says a certain bridge excuse me, a certain bridge arch is in the shape of the top half of an ellipse. It's 134 feet wide and 27.9 feet high. So you got a top half of an ellipse. I'm just going to draw what that would look like as best I can. What we are told is that it's 134 feet wide. It's going to be 134 from left to right. And from top to bottom at the center, since that's where it's highest, is 27.9. I'm just going to put the center here in the middle as our reference point, because that's where you'd want to put it anyway. Alright, so that's our picture. The question is, at what horizontal distance from the center of the arch is the height equal to 15.4? Alright, so what this is asking us is, as we move left and right, that height's going to drop. It's going to eventually get down to 0 on both sides. The question is, how far do we have to move left and right to make it 15.4? Okay, so what we're trying to do, we're going to have one answer because it's the same distance to the left and to the right. Call it x. See if I can make them look a little more like an x. And it's asking, what is x when y is 15.4? That's the question here. So we've got, we know it's the top half of an ellipse. We have that it's 134 feet wide and 27.9 feet tall. Now, one thing that I want to point out here is this is sort of like the first couple of problems where it doesn't matter which one A and B are, because nothing about the focus is important here. So I'm just going to put x squared plus y squared over some blanks. We'll fill in the denominator in a second. Right now we've done a few problems here. We can scroll up just a little bit, but I will go ahead and remind you what number goes under the x squared is how far the center is to a vertex. And that's going to be exactly half of how wide it is. Okay, so if this is 134 feet wide, that's from vertex to vertex. Half that distance is going to be from the center to the vertex. That's why it's called the center. So we would just do half of 134. Go ahead and write that in. And that is the A or B, just the number we're going to have to square. The 134 divided by 2 is 67. And what goes under x squared is 67 squared. If you want to go ahead and write down what that is, you can. I'll do that in a second. Right, now the number that goes above or below the y squared is b squared. Right, but since this is already half of an ellipse, this is not something we want to cut in half. 27.9 is exactly our b because it's already half of the ellipse. Let's go ahead and write that in. But once again, we have to put it squared. And don't forget about that. So we got x squared over 67 squared plus y squared over 27.9 squared equals 1. Now that we have our equation, we can get back to what the question was asking. It's asking, what is x when y is 15.4? So what we want to do is exactly that. We want to plug in y equals 15.4 and solve for x. And once again, you're dealing with numbers here, so simplify as much as you want to as you go. I plugged in everything first before I simplified. x squared over 67 squared plus 15.4 squared, right? Because this is y, so don't forget to square. You're plugging in for y, not y squared. Get rid of that weird looking thing. Over 27.9 squared equals 1. I know that's a lot of messy numbers, but you can use your calculator. Just realize that you want to round to 2 decimal places, so make sure you round plenty far as you go through. 67 squared is 4,489. Now I just did this whole thing in the calculator once to figure out each one. 15.4 squared plus divided by 27.9 squared is about 0.34067 equals 1. And now if you we're solving for x squared here, so we want to subtract the 0.34067 away from each side, and when we do that, that x squared over 4,489 equals 1 minus 0.34067 is 0. Now that number doesn't make sense, hold on a second. Now there we go, 0.65933. Because I wrote the wrong number, now I gotta double check myself. We would continue solving for x squared, we would multiply, or solving for x, we would multiply each side by the 4,489. So I'm going to write that on my paper. Wait, don't write the wrong number. So once you do 0.65933 times 4,489, because that's 2959.73237. That's what x squared equals. Run out of space. You can't add it on the side. 0.23. I lost my spot in. 73237. X squared equals 2959.73237. And then if we do the square root of that number, just going to do it like this, square root of that number is 54.40 rounded to 2 spots. Now this just asks for the distance away. So the distance away from the center is 54.40. If we care about the units, we would write feet. Alright. But we don't have to write it as 2 separate coordinates because it asks what distance, then asks what the coordinates are. And that's definitely the harder of the two. I just think this next one's kind of interesting. If you've never heard of a whispering gallery, they're pretty interesting in how they work. And this problem really describes it for you. A person in a whispering gallery standing at one focus of the ellipse can whisper and be heard by standing at the other focus because all the sound waves reaching the ceiling are reflected straight to the other person. And this isn't something that's fake. It sounds kind of weird, but you can be standing hundreds of feet from someone and hear someone whisper. There's a whole Wikipedia page about whispering galleries and where some are. We have a lot in the United States, so once we're allowed to travel again, if you find yourself in any of these areas, it'd be pretty interesting just to check it out. But anyway, we'll go ahead and just answer the question. Now, it says, if a whispering gallery has a length of 140 feet and the foci are located 30 feet from the center, find the height of the ceiling at the center, down to the nearest 2 decimal places. Okay. So we've got a similar setup here. Think about a gallery. It's not going to be an ellipse. It's going to be half an ellipse because we have a floor here. Okay, so there's our whispering gallery. It has a length of 140 feet. Our center is smack dab in the middle. And then 30 feet away from the center are the foci. And we know they're on either side from what we were talking about before. But it's 30 feet either way, so left or right. The question is, what is the height of the gallery at the center? Meaning, if we're right here at the center, what is the height up to the top? One thing you want to realize here is that this is really just asking what B is. And if we're talking about an ellipse, we're kind of looking at this picture here, but the height right above the center is B. Alright, but really this question is asking us, what is B in our ellipse? That's what we want to figure out. Now, one thing to keep in mind here is it's not asking us for the equation of the ellipse. We can write it down. It certainly doesn't hurt to write down. We would have x squared over a squared because the major axis is horizontal, plus y squared over b squared equals 1. And c is the distance from the center to a focus, so c is 30. And a is the distance from the center to a vertex. Right? The vertices are on either side. And just like last time, when you're told the width of the ellipse, right here, you cut it in half. So the A is 70. Right, it is half the distance because we go 70 left and we go 70 right. That's how we make up the 140. Right, but once you have the question here, what is B, and you realize your information, the only way to figure that out is that formula again. I was about to write it simplified, but we have c squared equals a squared minus b squared. Plug in our c and our a. And c is 30. A is 70. Square each of those out. 30 squared is 900. 70 squared is 4,900. Subtract the 4,900 from each side, we get negative 4,000 equals negative b squared. The negatives knock each other off just like they always have. We get b equals the square root of 4,000 and we want that rounded to 2 decimal spots. Square root of 4,000 is about 63.25. And that's what we want. That's what we want to know. What is B? What is the height there? Now, one thing I mentioned before, and I'll mention again, is A, B, and C, and everything that we're going to do for this section. Now that we've done it in the next section on hyperbolas, is they're always positive. So whenever you do stuff like this and you're doing square roots, you should never get the square root of a negative number. There's no imaginary numbers. But it's going to be about as nice as you can get. If you forget a negative sign, like it's always possible, it's probably not going to be something that's a big deal because it'll go away eventually. But you do want to keep that in mind. If you use this equation incorrectly, probably the main way you're going to use it wrong is mixing up the two equations. And if you do that, you'll almost always certainly get a negative square root, which cannot be. So that's a nice way to check yourself as well. Right, but this is what we need for an ellipses. And if you watch all this, hopefully you watch all this before Thursday, our class, Tuesday, Thursday. If you watch this all before class period on Thursday or next Tuesday, and you have questions, definitely ask.